Today we are going to see the IP address. Okay. First of all, we need to understand what is IP address. So there are two types of IP addressing. One is IPv4 and one is IPv6. Okay. Now let me tell you why is the need of IP address and why we need IP address in our networking component. Let's say if you want to communicate between the two devices. Let's say I just wanted to communicate between a PCA and a PCB. At that point of time, both the devices should know each other address, because let's say if I want to send a letter from one place to another place, in the letter I need to give the address, I need to provide the address, or else the postman won't be able to deliver the packet, or let's say the letter from one address to the other address. The same case happens with IP address. In networking, what happens, every device has that unique address, we call it as a IP address. IP address works on layer 3. IP address works on layer 3, and there is also MAC address, it works on layer 2. Now the difference of IP address and MAC address is IP address is a dynamic address or can be a static address, and it is a temporary address, but MAC address is static. MAC address is what? MAC address is static. When I say MAC address is static, it means MAC address is physically MAC address is physically derived into the NIC card. MAC address is simply, you can say, burned in address. It's a BIA address, burned in address. MAC address simply, okay, soldered. MAC address soldered into NIC card. But IP address does not work in that way. IP address, you can either purchase a static dynamic IP from the ISP, or the ISP can hand you the IP address based on your need. To understand the difference between a MAC address and IP address, so MAC address works on layer 2, IP address works on layer 3. Right now what we are studying the IP addressing part. Okay, so if you see, there are two variant of IP address, as I mentioned, IPv4 and IPv6. Now if you see, IP uses packet called IP packet to carry information. Every IP packet is a single unit of information, and beside data, it carries information to determine where to send the packet. Means it needs to identify the packet, and it needs to also determine where to send the packet. It determines it by looking into the destination IP address field. As I mentioned you, OSI is very important in order to learn the networking. So IP addressing works on network layer of the OSI model. IP addressing works on network layer of the OSI model. IP is a connectionless. IP is connectionless. Why I meant connectionless? Imagine like this. I am sending a letter from one place to another place. Okay. When I send it, I'm like, okay, I have sent it. Now the other party must be receiving it. But there is no way to check whether he has received or not, unless we call that guy to ask, have you received it or not, right? The same IP, what IP said, okay, you hand me the data, I will try my level best to deliver it, but I won't take a guarantee. IP said, you hand me the data, I will try my level best to deliver it, but I won't be guaranteeing you that the data will be delivered successfully and safely. That is the reason IP is a connectionless protocol. It is not connection oriented protocol. We will see what is a connection oriented protocol, but right now IP is a connectionless protocol. Okay, every packet is treated independently. There is no order in which the packets are arriving at the destination. Means, let me tell you, imagine there are 10 packets we are sending from this like sender A to sender B. The 10 packet can take different route. It is not like there is a single route and packet 1 2 3 4 5 6 7 8. No, they are not going to follow the order. Each packet will travel independently. Each packet will be treated independently. Let's say packet A is taking a straight route, packet B is not going to take a straight route, it can go a circular way. It depends. Okay, so you, as I told you, IP is a connectionless, it is not connection oriented. IP clearly mentioned, see, I am a connectionless protocol. Okay, if everything is good in the network, yeah, packet can be reached in order. But if everything is not good, there is a congestion in the network, If there is a congestion in the network, packet 7 can go out of order and reach first. Packet 1 can be reached after packet 7. That is the reason of it's out of order delivery. Because IP is what? IP is connectionless. Got the point? Any doubt here? No, right?